Okay, dear student, let us see what is there in this question. A mass is attached to one end of the rod and made to rotate with constant speed in a vertical circle. Okay, the scale diagram shows the weight W of the mass at an instant when the rod is horizontal. Draw on the scale diagram an arrow to represent the force exerted on the mass by the rod. Okay, fine. So let us move to this question now and try to understand a bit about the background. You see, there are two type of circles, like circular motions. So the first one is horizontal, another is vertical. In the horizontal circle, it's somewhat like that we are not considering the effect of the gravity. So we do not consider that. So every time v is equal to r omega, the velocity does not change. And yeah, we would be using this. The formula for the centripetal force becomes mv square by r, or mr omega square. So these are the formulas that we do. It's a simple circular motion, and that is known as the horizontal circle. When it comes to the vertical circle, the things are bit problematic. So what happens is, like, just assume that there is this string and this is a body which tries to move in a circular fashion. So obviously, when it is like at this point, let us say, or when it is going in, it is increasing its height. So gravity is acting against it. So when it moves from the point A to point B, let us say, like, I will call this B and this C. Let us say it is going from the point A, B, and C. So it is increasing its height. Gravity is acting against it, and so the velocity keeps on decreasing. And when it comes from C to A, like via D, I can say CDA, the acceleration is positive, and so the velocity increases. So the velocity becomes minimum at C and the velocity is maximum at A. So this is vertical circle is one such case in which the angular velocity, or or the tangential velocity with which the body is moving, it is a variable. It is like, clearly we can see that at the point C the velocity will be minimum, at the point A the velocity will be maximum. This is the characteristic of a real vertical circle. But this case, they are talking about the vertical circle, but actually, this is a kind of special case of a vertical circle. Why? Because it is attached to the rod, it is not a string, and also it is made to rotate with a constant speed. So, omega in this case, because the direction is downward, I'm drawing like this, omega is constant. It means the body is moving with the same velocity everywhere, whether it is going upward, whether it is going downwards, wherever, but the velocity remains the same. So this becomes kind of case of a horizontal circle, because the velocity v is equal to r omega we are able to use. We would be considering the centripetal forces and all that, so the velocity does not change. So be very very careful at this point. IB plays this game many a times. They call it vertical circle, but it's not a proper vertical circle. Okay, so be very careful. In the questions that I have uploaded for paper one, I have completely explained what is a vertical circle. There is one video in which I have given you the complete theory about the vertical circle also. Please try to find that video and see it. So this is the vertical circle. But what is happening in this case now? So now this case is different. So what kind of case is this? Like, for example, there is an external motor attached to this. So it's kind of a table fan, which is moving in the vertical circle, but it is attached with the motor. So it is moving with the constant angular velocity omega. So now let us read this question now. The scale diagram shows the weight W of the mass at the instant when the rod is horizontal. So when the rod is horizontal, draw on a scale diagram an arrow to represent the force exerted on mass by the rod. Okay, we have to be very careful when this kind of a question is there, because they are definitely, this kind of questions are very tricky. So what is happening now? Horizontal direction. So one thing is clear, like, because it is moving at a constant velocity, gravity does not affect it. Now the question is, weight is acting on it. So why the gravity is not affecting it? Now, obviously, there has to be a counter force that will cancel the effect of the weight. It means, first of all, there will be a force in the vertical direction that will be equal and opposite to weight. This will be the force applied by the rod on the mass. So this is the vertical force. Now, it is moving in a circular motion, so there has to be a centripetal force also, so there will be some horizontal force also. So this will be the horizontal force and this will be the vertical. So we can clearly say that the force, this should be the F rod, you can say. So the force applied on the mass by the rod, okay, or you can just call it F, no problem. So this is the force F that is applied. So what we know about this is that the vertical force will be equal to weight. So there are two squares here, so two squares will be upward. And for the horizontal direction, it could be anything because the velocity could be anything. Centripetal force is equal to mv square by r. So we are not sure about the velocity, so it could have any value. So we can just assume it to be this. This will be the net force that you have to draw, and this is the final answer for this question. So A is done. If there is any doubt, students, you can please mention that in the comment section, no problem at all. And we would be conducting a class on Sunday for the doubts. You can ask your doubt at that time also. Explain why the magnitude of the force exerted on the mass by the rod is not constant. So now this is another thing, that this force that we have drawn here, this force is not constant. It is variable with the from position to position. And why is that? So we have to explain it. So let us move to the diagram now. Okay, so this part will be a bit tedious and it will be consuming a little time. So be careful now. We are going to consider two positions. One is at bottom and one will be at top. So first of all, let us concentrate at the bottom. So the weight is acting downwards and there is a force. So we can say this is the force by the rod, or you can just call it tension, because when we were using strings, we used to call it tension. So it is not right to say that it is the tension in the rod, because tension is used only for the strings. But just for the comparison sake, I'm using the word tension. You can call it Fr also, or something, force in the rod, isn't it? So this is the tension T. Now because of this, there will be some centripetal force. So at the bottom, centripetal force should be equal to T minus W, because centripetal force will be definitely in the upward direction. So T is equal to W plus Fc. So at the bottom you can see that the tension or the force in the rod is maximum. So here the tension is maximum, and centripetal force, like, one more thing that you have to note. Now this rod is moving with a constant angular velocity, and the centripetal force will be having a constant magnitude, like mr omega square. So m is the mass, r is the radius, omega is the angular velocity with which it is moving, and that is constant. So we can clearly say that the centripetal force will be constant. So this force is constant and weight is added on it. So definitely tension is having a very big value here. Now, so at the top, let us see. At the top, so first of all, the tension will be downwards, or you can say that the force by the rod, so that will be downwards. And because it does not want the body to, like, detach. So there is a force on the body by the rod downwards. Now the weight is also downwards. So we can say at the top, the centripetal force is created by the sum of T plus W. And from here we can say that T is equal to Fc minus W. And obviously Fc, we cannot say like, okay, fine, Fc minus W, it should not be zero because it is moving in circular motion. So tension will be there. So at the top, tension is lesser because Fc is having a constant value, which is mr omega square. This is also mr omega square, it's a constant value. So here they are subtracting, here they are adding. So we can say that here the tension is minimum, and at the bottom the tension is maximum. Clearly the force which is applied on the body by the rod is not constant, it is a variable from a minimum value to the maximum value. The minimum value can be zero, that the tension will be zero, so Fc will be equal to W, and we can say that it will become zero. Even that is possible. Okay, dear students, so this is how we do this question. And so this is Professor Varun. Thanks for joining. Please tell this thing to other students also. Tell them to join the YouTube channel so that they can be benefited with these videos. Thanks for joining. All the best. Bye.